We're gonna, in this example, we're gonna look at this vector here, and it's -5, -14, 16, and see if we can express it as a linear combination of these three vectors, v1, v2, and v3. Okay, so to express this vector, if it is expressible as a linear combination, that means that the vector -5, 14, and 16 is going to equal to some constant times v1 plus some constant times v2 plus some constant times v3. And so what we're going to look for is what, if there are any, we can find numbers c1, c2, and c3 such that the scalar multiplication and vector addition is equivalent to this vector over here. So just kind of looking at it and starting somewhere, I usually just start with the first one. And since c1 is a 1 there, I'm going to see if just using positive numbers would work. So if c1 is, let's say, just 1, then that would mean, so if I'm thinking like c1 is equal to 1, that would mean that c3 would have to be equal, make that a -5. That would have to be a 6. So 6 times -1 is -6 plus 1, c1, because -5, so that would work. Okay, and c2 doesn't play any role here because of the 0 for the x coordinate. If we look at c2, then along with this one, c3 doesn't play a role here, so it's this one between c1 and c2. So I have a -14 here. This one's negative, so but I've already said that c1 is equal to 1. That means that c2 would have to be a negative. Well, if it's a -3, that would make that -12, -13. So that's close, but not quite. So let's try that, making that a -4, make that a -16, -17. So neither of those will work. And so we could try some fractions and see if maybe that would get us there. But we'll try to stick with integers for now. And so you can see that this combination is not going to be it. So I have a suspicion that if we try c2, c1 is equal to 2, that might get us somewhere else, somewhere close. So let's try that one and see what happens. So if c1 is 2, that would be 2. And what would that mean? C3 would have to be, well, if I'm going to add 2, that means 3. If I'm going to add, that would have to be a 7. 7 times -1 is -7 plus 2 would be -5. Okay, so that checks. Let's see. So if this is 2, C2 times -1 is -2, which means that C3, if C3 is, let's say, -3, -3 times 4 is -12 plus a -2. Hey, that would work. Okay, so this is -3. That one will work. Okay, and let's check the last one just to make sure. So this would be 6. This would be positive 3. So that'd be 9 and 7. 9 plus 7 is 16. Oh, that works. Okay. So it looks like if we choose 2 times 1, -1, 3, plus -3, I guess we could write that as a minus sign, but that's okay. It's a 4, it's a 4 and a -1. Trying to figure out what that looked like, a minus sign there. And then plus 7, -1, 0, 1. Okay, this combination gives me -5, -14, and 16. So we can write this vector as a linear combination of the vectors v1, v2, and v3. Right, I hope that is helpful, and I'll see you in the next video.